Continuing solving for linear systems of equations, let's learn a new method. But for this new method, let's start first with new equations, easier equations. So let's replace the 2x minus y equals 9 for 3x minus y equals 5, and the 3x plus 4y equals 8 for 4x plus y equals 2. Now that we have these easier equations, let's solve using the combinations method. And the combinations method, as the same name says, we have to combine the two equations. What do we mean by combine? Like combining like terms, doing additions and subtractions. So let's put the line of the operation and let's combine. So let's first do the x's. We have 3x plus 4x because both of them are positive. This is combining like terms. 3x plus 4x is 7x. Now let's do the y's. We have minus y plus y. And we have learned all of these lessons, when we have opposites, they cancel. So minus y plus y equals 0. And this is a good thing because for the combination method to work, one of the variables must cancel when we're doing this combination. If the variables don't cancel, then the combination methods gets more complicated. And now that the y's cancel, let's also do the numbers on the other side of the equal sign. 5 and 2, they are both positive, so 5 plus 2 equals 7. So what we get in the answers in the below the line is a new equation. So let's write this new equation by separate. Let's start by, well, 0, adding plus 0 doesn't really make a difference. So let's take it out of there. And let's take our 7x equals 7, and we write a new equation. This equation only has one variable, only has x, so we can solve for x. We know how to solve for x. This is a one-step linear equation. And one-step linear equations, all we have to do is, well, the 7 is multiplying the x. The opposite of a 7 multiplying is a 7 dividing. So the 7's cancel, but if we do it on one side, we have to do it on the other. Then 7 divided by 7, they cancel out. So we get x equals 1. We have a number. We have x equals 1. We now can use the x to solve for the y. And to do this, we just pick one of the two equations remaining, any equation. Let's pick the bottom equation just because we don't have any negatives, but we can pick either of the equations. And let's write it down. We know that x equals 1 and x is part of the second equation. So as we learned from the substitution method, we can substitute. So the combination method, it also uses a substitution. So we can take the 1 and replace it for the x, same as we learned in the substitution method. Now, one more time, let's not forget this is a multiplication. 4 times 1 equals 4. And this is one more time, one-step linear equation. We have the 4 is positive, so we have to do -4 to cancel, but if we do it on one side, we have to do it on the other. And then we do 2 minus 4, rules of signs, is equal to -2, and that's it. We have a value for both of the letters. We have a value for x, we have a value for y. X equals 1, y equals -2, and these two are our solutions. We can plug them back into our two equations, and we're going to get the respective answers. So it's good. Now, the substitution method, the method we learned in the previous lesson, is a little bit longer and sometimes more complex. This method, the combination method, is a lot faster, but sometimes it's trickier, and not every single time we will be able to apply it right away. Sometimes we have to do extra steps, like in this problem. This is the problem we use for the substitution method, but let's solve it now using the combination. We put our line of the operation, and let's look at this. The 2x and the 3x, they're not going to cancel each other. The -y and the 4y, they're not going to cancel each other as well. We don't have any opposites there. And this is a problem because, remember, for the combination method to work, one of the variables must cancel, and we're not getting any variables canceled. So how do we do this? How do we fix this? For that, we need to take one of the equations. Let's take the top equation, and we need to multiply it by a number, any number. Sometimes it's a fraction where we have to multiply. But we have to multiply times a number such that something will cancel. In this example, Let's multiply the top equation times 4. Y times 4, well, let's distribute it. This will be 4 times 2x, which is 8x. 4 times negative y, which is negative 4y. And 4 times 9, which is 36. Yes, we have to multiply times all of them. So let's replace it. We get 8x minus 4y equals 36. If we combine them now, because of that multiplication times 4, let's see what we get. We get 8x plus 3x is 11x, and we get minus 4y plus 4y. So finally, we have some opposites that are going to cancel. So we got it. We were able to cancel one of the variables. So in order to apply the combinations method, one of the variables must cancel. And sometimes we have to multiply one of the equations, or sometimes the two equations, we have to multiply them so we can get something to cancel. And finally, 36 plus 8 is 44. Now we write our new equation, forgetting that we have a 0. Plus 0 doesn't really make a difference. And we put 11x equals 44. This is a one-step linear equation. We know how to solve them. The 11 is multiplying, so we have to divide by 11. The 11's cancel, but if we do it on one side, we do it on the other. Then 44 divided by 11, we get x equals 4. Now, we pick one of the remaining equations. Let's pick the bottom equation again. It just looks easier, but we can pick either of the equations. We'll still get the same answer. Let's write it down. And what do we have? We have 3x, but we know that x equals 4. So if we have 3x and x equals 4, remember, we can substitute it. We can interchange them. So let's replace the x for a 4. Not forget it's a multiplication. And let's do the operation. 3 times 4 is 12. And this is a two-step linear equation. We also learned how to solve these ones in lesson 3.2. Positive 12, so we have to do minus 12 to cancel. But if we do it on one side, we have to repeat it on the other. 8 minus 12. We do the operation. We get that this is negative 4. And then the 4 is multiplying the y, so we divide by 4. The 4's cancel, but we have to do it on both sides. Minus 4 divided by 4, let's not forget the rules of signs. Y equals negative 1. And these are the same pair of solutions we had using the substitution method in the previous lesson. So no matter which method we use, we still get the same answer.